Hi everyone, welcome back to my channel. Today we will try to understand how Kubernetes work on Azure platform, how we can configure it, how we can deploy our app over there in Kubernetes environments. So we'll see, draw one diagram where we'll see Kubernetes as a result. In result, we can have multiple buildings. In multiple buildings, particular building, we can have multiple rooms. So the hotel or resort is a Kubernetes and the buildings are the nodes, and then the rooms inside those buildings are pods for us, pod, and under those pods we have containers available. Simple ideology. So we'll try to draw one diagram on this. So here we will have uh, so this is our complete what we call resort. We call it the Kubernetes resort or hotel. Okay, now inside that we have multiple buildings. So this is one building. We call it building one. Primarily is a node in language of Kubernetes. So we call it node A. And inside that building, we will have multiple rooms. So I'll create multiple rooms. So, this, for example, this is room 101. This is 102. In technical terms, we call it pod, pod. Inside those pods, we have container where our application resides. Container runs on top of virtual machine. So this uh, this node is act as a virtual machine, and under that we have multiple containers on top of VM. Then we can have another building as well, that is called building 2. Again, building 2 is kind of one node for us. We call it node B, and here we have multiple rooms. So those are kind of replicas. If, for example, the traffic is very high on this particular pods, then probably the building 2 has different containers automatically boot up. So different containers will be boot up here accordingly if the traffic is high on building 1 or node 1, node A. So there would be some controller. So we call it K8s control plane. It's a hotel manager with clipboard. So we call it hotel manager with clipboard, which manages checking the health of those buildings. Where the container is down, then it will boot up the next containers on different room or pod. So it will monitor health. So this is the simple diagram we have how to understand Kubernetes. Now we will try to configure these things in Azure platform. So in order to do that, let's go into the Azure platform. So first, what we need to develop such kind of architecture. Probably you need container, then you need Kubernetes. So in order to store the container or Kubernetes, what services is required in Azure. Let's talk about that. So container is kind of image of Docker file. So we will have some Docker file which we will make it containerize, right? Once it is containerized, it will store somewhere. That is, we called it Azure Container Registry. Then we have a Kubernetes cluster that we will create through Azure. So there is a Azure Kubernetes cluster, Azure Kubernetes services. We call it Kubernetes services. Okay. So let's first create a container registry. So we'll search for container registry. This is not this one, registry. So we start by creating container registry first. So we'll search for container registries. This is the one. Then we'll create one registry where we'll store our Docker image. So it's basically then we'll build the Docker image, we'll create a container and we'll store it here. So it is the place where the container is going to stay. We'll create one resource group. So let's call it Kubernetes. RG. Okay. Let's have some name. So it should be unique. Let me put my name here. Yeah, it is available. Let's put this Australia is reason. And instead of pricing plan, let's make it basic. And select this RBAC registry permissions. It's a simple, it will allow all those resources under that as in form of RBC, resource based permission. So role based role based account permission, registry permission. We'll click on review plus create. Click on create button. Started initializing deployment. In within few minutes it will be deployed. Let's wait for that. The validation is passed. Then click on the create button. Okay, deployment is in progress. Yes, let's wait. Okay, I clicked on multiple times, that's why this message came up. But yeah, earlier one is creating. So you can see our deployment is complete now. We'll go to the resource. Here we'll see that it's successfully created. Now we'll try to create a Kubernetes cluster. So we'll search for Kubernetes. Okay, let's search for Kubernetes services. Kubernetes services. Go and create a Kubernetes cluster. Select the resource group which you just created, Kubernetes-RG during registry creation, Azure Container Registry creation. Same one. Then cheapest PRS, this cluster PRS configuration, make it dev test. It will not take any cost, so let it be default dev hyphen test. Then Kubernetes cluster, you can name it like anything. I'll call it my, okay, it's already there. My AKS cluster. Reason I chose Australia is, okay. Then nothing needs to be changed here. Click on the next button. Search for this node pools. Okay, define how many particular VM instance you want where you can boot up your containers. So this is a default one. We can change it according, even though we can go and update it if we need. So in our case, let's minimum 1 and the maximum let it be 3. Okay. Then This is a machine we chose, 7 GB memory and two CPUs, and the zones we have zone 1, 2, 3. Let's update it. We don't need to change anything. We'll click on this review and create. Here we have one thing, integration, where we can select the container registry as well, but we'll do with the command, through command, instead of this. So click on this review and create. Probably should be, otherwise it will give us the error and the reason why it is not able to validate. So let's wait. Okay, so validation failed. Let's see the reason. Okay, so it's saying that zone 1 for resource agent pool is not supported. For this Australia central or west, whatever, east, Australia east, there is no zone 1 is not supported. So we'll go on the node pools again, agent pools, and untick the zone 1 from availability zones. And let's try again. Validation is in progress. So this way we can debug our errors and find the root cause why it is not happening. It's also very important to understand. Again, it got failed. Let's see the reason. Try to see the reason. Okay, zone 2 is again not supported. So we'll do one thing. We'll remove all of the zones. So it will be by default selected by their sense. Okay, update, review and create. Validation in progress. Okay. Yeah, so this time we got this error where it is saying that this particular image is not supported, standard DSB2, the one we have chosen right now. If you go here, this is the one right now we have, this standard DSB2. Let's choose a different one. Let's choose some higher side, otherwise it will keep going. So in the D series, let's select this one, charging quite good actually, this one. Fine, let's select this B6. Update, review and create. Validation in progress. Yeah, so if you see, this is successfully validated. We hit on this button called create. Initializing deployment. It will take 2 to 3 minutes at least to create a Kubernetes cluster. So we'll wait for that. You see, it's deployed now. Took a lot of time, 8 to 9 minutes at least it will take. We can go to the resource. This name is my AKS cluster B. Took this name. Here you see it's pricing tier free. This node pools, one node pool, and then container registry we need to attach it, right? So we'll do one thing. We'll create our app first and then deploy the Docker image or container registry, and then we'll try to map it with this Kubernetes cluster. Okay, let's go into the PyCharm screen, IDE screen, any IDE you can use. Okay, now you see my screen where we have some code. This is main.py file where we have some basic application, that's hello Azure Kubernetes. We can return it like response Azure hello Azure Kubernetes. cluster. Okay, then we have the Docker file where how it is going to be run this particular main.py file or our FastAPI server data step are written. So we are using this Python image. It's a lightweight Python 3.9 slim. Working directory is app. Then we are copying our requirement.txt. In requirement.txt is simply FastAPI and UB There are two libraries we are using. Then we are installing all those Python libraries. We are copying the current code into container location, Docker container current directory, which is app. Then we are exposing the port 8000 where we are trying to access our application. And these are the this is the ubicon command to run it. Very simple. Now we have another file called deployment.yml where we have all the aspects about what are the templates, what are the which is the image name. So we need to update this image as well because this is our container registry path. So in this case is actually Azure, Azure ecr.io, and this is application name we are trying to build. So we'll create this name of the image during command. So you will see what I'm exactly telling. This is this is the CPU we are giving the request required CPU 250 MB of limit. Then we have service.yml file. Here we what kind of services it is, kind service, then the name of the service, FastAPI service. So it's helpful for service discovery. For example, there is another container that is React.js you're deploying based on the React front-end application. So you will call the backend API not through API through IP, some IP address. Instead of that, you just put HTTPS simply. Let me HTTPS, or it will be FastAPI service. Inside the container, you can call it this way. You don't need to put the IP of that, whatever it is. So this is very flexible in case of Kubernetes. So these two files simply we need to have. This one we can delete, it's not required. Okay, sorry. Yeah, okay, let it be. Now we'll execute our command. So the first command will execute the AZ login. We'll do the login first. Authenticate with our account. You have logged into Microsoft Azure. Okay, that is successful logged in. We have just did. Now we'll execute command called acr login, and we'll log in our container registry. So directory will be default. We don't need to change anything, so it is fine. Now we'll select the container registry. We'll log in into the container registry. So acr login hyphen name, then the acr name. So it's Akshay Tiwari. Yeah. So remember, you need to have your Docker service needs to be up in your local while executing this command. So it was already up for my case. So you can see login succeeded. Now next command, we will execute this build command where we simply create the Docker image from our Docker file. So we'll create the Docker image over our container registry, our Azure Container Registry, that is our personal repository. And the name of the app is FastAPI -app colon B1 version. And at the end we will have dot. Okay, Docker build. This is the tag. So this is the build tag, but it is happening in our local right now. This is happening in our local. Now we'll try to push into our container registry. So for that we'll have simple command docker push, and the container registry path .ecr.azure.ecr.io FastAPI app colon v1. So this will pushing our image, Docker image over in our Azure Container Registry. It's a basically container which is pushing. We are pushing. Now we'll connect. We'll see first whether this is there or not. So we'll do one thing. So if you go back and search for container registry, this is the one we created, and go in services, click on repositories. Here you have this FastAPI app. We just pushed it, this B1 version. So yeah, it's there. Now let's go back to the pie chart again. Yeah, it's pushed now. Let's connect the container registry with Kubernetes cluster. So for that we have this simple command where we'll update the source in repository source for Kubernetes cluster. So it's AKS update hyphen n, the Kubernetes cluster name. That name is my AKS cluster. The group we are using the Kubernetes hyphen rg. That is also fine. Then we are attaching this Azure Container Registry called Akshatiwari. This one. Let's execute this command. Yeah. So you can see it's add role propagation done 100%. Now started in progress. Will take probably 4 to 5 minutes at least it will take. Let's wait for that. So you see it's successfully linking is done. Now we'll update this deployment YAML file and service YAML file. The next step is we'll execute this command where we can see what are the credentials we have for the resource group. So let's verify that as well. Okay, so it will update in our local. That is very important. So this is also important in our username, and then cube and .cube.config we will have this configuration available. That is also important. Now we'll apply the new deployment YML file. Okay, this is our deployment.yml. Now we'll apply the services.yml, service.yml. Don't worry, I will put all those commands into description so that you can follow along. Once this is done, then we'll deploy our perform our deployment for in auto scale mode. So for that we have a simple command kubectl auto scale deployment, and the CPU percentage minimum we have 50%. If it is we are going beyond that, it will auto scale to another pod which we talked about. The other container will boot up accordingly. So yeah, this is done. Now second thing we'll do one we'll try to see whether we are able to access it or not, right? So for that we have this command kubectl get service fast API. This particular service we named it right, fast API service in service.ml. If you see, so you see it's running, and this is the external IP we have assigned. So we'll copy this one and try to see whether we are able to access it or not. We'll go back into the browser, try this command, this IP. So we had that message hello Azure Kubernetes cluster, and that's working quite fine. Now we'll try to see some of the scenarios where we are like getting heavy traffic. In that case, how it will create a different pod and how it will scale accordingly, right? That we will see. For that, we'll go back to the PyCharm screen again. PyCharm. Okay. Now we'll do one thing. So we can see we can have this way to create a huge traffic. So in while loop, we are after 0.01 seconds, we wget our fast API service inside the container. I'm doing it Kubernetes itself. So in order to see how many pods are booting up, how many services are running, for that we have specific commands which helps on that part. Okay, so that command is nothing but Kubernetes kubectl get HPA. Let's try kubectl get HPA. Okay, so this is a CPU 1% consumption is only out of 50%, and the minimum pods are 1, maximum pods are 3. Right now replica is only 1. Okay, we'll try to create a traffic and see how many how it is scaling up. So instead of so this command and -w is the one which gives us how does it look like in the runtime itself, and we'll execute this command to send a lot of traffics, lot of request, and see how does it is increasing the CPU percentage, and then is it booting up the next one or not. Okay, let's wait. Okay, this you see we are continuously bombarding the request. Currently it's 0% utilization of this particular pod. Okay, should be. Let's wait. Yeah, it's request are going. Or we'll do one thing. We'll create another. We'll execute another command, same command, to bombard the request so that we'll see that happening in front of our eyes. Right now it's 0%. Okay, now see it's 30%. Yeah. Let's create another one. This one. This will not help. This command is okay. Yeah, this is the one. So already used, so we'll create a different name of that. Load generator 1. How does it? Okay. Okay, again it's setting. Let's see. So we are hitting from two places, and yeah, it's now it is stacking up very fast, right? So in the runtime, we can see by use this command kubectl get HPA -w. What we want to see is after 50% what will happen. Will it the replicas will be increased or not, right? Just wait. Okay, I'll pause the video for a few minutes. So you see that now the replicas count is 2. the CPU consumption is more than 50%. So it boot up two node pods for us. Yeah, that's the thing with the Kubernetes cluster. This is one of the benefit of having different uh, uh, having making up different pod based upon the current pod configuration or the traffic we are getting. If the node is, for example, pod is down or container is down, then it automatically boots up the different container or pod without having any downtime. So that's a second benefit. Even though if your node is down, the BM, then it is again, if you have multiple, you have configured your Kubernetes cluster in multiple zones and multiple VMs you have given from 1 to 3 in our case. So it will create a different virtual machine and they'll create a different pods inside those virtual machines. That is, virtual machines are nodes, and under that we have different pods which are the container essentially. So that's how this is quite good actually. And yeah, thanks for watching the video. And for such videos, like and subscribe my channel. Thank you.